Morning friends, today I am going to demonstrate you the LDP over segment routing scenario. So there could be situation in your network that few of the nodes are still running LDP and few of the nodes are still running the segment routing. So possibility could be there that you are still migrating your network and you have multiple MPLS technologies running on your node. So today I am going to demonstrate how the interworking works between LDP and then segment routing. So in the earlier labs we saw how LDP to SR or SR to LDP works. But today let's see if there is separate domain in between two LDP domain. If you look at the diagram at the right hand corner, R1, R2, R3 are part of the LDP domain, R3, R4, R5 are part of SR domain, and the R6 is part of the LDP domain. So here I am running the ISIS level 2, flat ISIS level 2 throughout the network. And LDP and segment routing is already enabled on these nodes. So node R3 and R5 are running both LDP as well as the segment routing. So let's see how R1 can reach to the R6, the destination in another LDP domain. Let's check this trace route for that. If you see that 10.6.6.6 it belongs to R6 and 10.1.1 is from R1. If you see the trace route, it is weird because till R3 we have the label assigned by the LDPs. So 24005 and 24010 means R1 has pushed the 24005, R2 received is swapped with the 24010 and R3 received 2410, but R3 didn't have any label to swap it with any other MPLS label. And if we check the from the R6, we should see the same behavior. Let's take from let's try to reach from R6 to R1. So we see that we have pushed the label, means R6 has pushed the label 24009. It's reached to the R5, but R5 don't have any label for that prefixes. And then again same for R4 as well. Then so once it's reached to the R3, then R3 has already received the 24002 label from R2, which he pushed on the packet and then push the packet towards the R2. R2 is doing the implicit null here. So this middle portion is the segment routing, and if we check on the R1, so this portion middle portion belongs to segment routing. As we discussed earlier that segment routing understand only the prefix-sid, and then index value advertised in the IGP. So based on that one, it's calculate the sRGB plus index value and it comes up with the label value. So if we check the R3's forwarding table, So you will see that R6 is unlabeled, and even we don't have any prefix-sid for the R6. So let's check the prefix 10.6.6. Let's check detail. So we don't have any outgoing label here. So if you see here, it's unlabeled. That's the reason you see R3 is removing that label and sending the IPv4 traffic towards the R6. And it will be the same for R5 towards the for the R1 and R2. So let's see prefix 10.1.1.1, same here. When the traffic is moving from R6 towards the R1, R5 receives the packet with the 24009 label, but R5 don't have any label to push or swap it on top of that one, or don't have any action for the label. So it removes that label and forwards the plain IPv4 packet as we saw here. And it is the same status for R2 as well. It's also the unlabeled. So if we try to trace route R2, is the same status. So we don't have any prefix-sid ID in this segment routing domain. Hence the middle portion highlighted in the diagram, the blue one portion highlighted in the diagram, is not able to calculate the label for that one. So to validate once more, if we can check the SAP entry, for the 10 for the R6, here we can see that it's saying that label is imposed null, and here we should see that labeled SR, but here we don't see any labeled SR here, and it will be the same status for the 1 and 2 on the R5. Label impose null, and there is no labeled SR. Same status for 2. And we don't have the labeled SR as well. Because these R1, R2 and R6 belongs to LDP domain, and segment routing domain or segment routing domain routers don't have any information how to calculate that one. If we calculate the data, if we check the database, so this is the database for R1, so we don't have any prefix-sid for that one. If we check the database for R2, so we don't have any prefix-sid for that one. R3 is the border router, so we should see the prefix-sid for that. So here we can see that prefix-sid index 3 for R3. For R4, this is the prefix-sid index 4. R5, it should be 5, prefix index 5. Then R6, we don't have any prefix-sid index. Means we need some mechanism so that segment routing domain routers should get the prefix-sid information for the non-segment routing domains. So So in this scenario, we can configure the mapping server, even we called as a SRMS, segment routing mapping server. So it can be anywhere within the segment routing domain. So you can have either virtual router, physical router, or any application which is acting as a mapping server. So in this our topology, let's configure R3 as a mapping server and let's see how it reacts. Segment routing, mapping server, prefix-sid index map, address family, IPv4. So we will need the entry for three prefixes, that is R1, R2 and R6. So for R1 my index value is 1 and I am not configuring any range value here. So range will be 1 by default, and attached flag we used it when we advertise this entry from level 2 to level 1 domain. For 10.2.2 it's a 2, and for R6 let's say it is 6. This is the segment routing information, SID information for the LDP prefixes. So we need to advertise these entries into the IGP domain. So this is mapping server configuration, but we need to tell the IGP to advertise these entries. Receive, by default it is on, we don't need to configure any receiving side, but we need to configure and ask IGP to advertise it. So we can go to ISIS and we can ask segment routing to advertise it into his network. So this is the complete configuration for the mapping server. So first we are configuring those entries and then we are advertising it into the IGP domain. So here I am running the Wireshark to just see how the packet looks like. So just commit the configuration. And we should see the LSP here. Yes. So let's check how exactly it advertises. So the router use the SID or label binding TLV. So if you see that this is prefix 10.1.1 and then SID label value is 1. If you check for 10.2.2, SID label value is 2. And if we check for 10.6.6.6, SID label value advertised is 6. So ISI is using the SID or label binding TLV to advertise these mapping server entries into the IGP domain. So let's go back to the diagram and let's check the mapping server entries. So 10.1.1 segment ID is 1, range is 1, last prefix. If we configure multiple range, so you can see here, and then last SID index. Same for 2, its SID index is 2. For R6, SID index is 6. Active policy. if you have multiple mapping server in your network and those entries are overlapping, so you can check this backup policy command here. But right now we have only single SRMS, so that's okay for us. So this entry has been advertised by R3 in the network. So let's check the status on the R4. Yes, R4 has received it. Let's check it on R5. Oops. Yes, R5 got these prefixes as well. And now if we check the forwarding entry for the R6, we should see the prefix-sid index for the R6. This is for R1, this is for R2. And if we check the forwarding table for R6, so this is the entry for that. So if we check the prefix information, so it's swapping with the label 16006. So if we check the earlier entry where it was just showing the unlabeled, and now we have the prefix, that is segment routing label for that particular prefix. So if we check the SAP entry here for that, so it marked as a labeled segment routing. So while doing troubleshooting, if you are facing any issue for the segment routing, first check that whether this prefix has been labeled as a labeled SR or not. Now you can see we have the label impose as a 16006. So if we check the previous entry where it was none. Now if we check the database, if we go for the detail, you will not get the segment IDs information here. So if you see, we don't have segment ID. So but to get the segment ID information, you need to check show ISIS database verbose. So now you can see the index value advertised by R3, because you will not see in the R1 and R2 because those are not advertising it. So mapping server is R3, so you should get those entries here. So for R1 it's advertising entry 1, for R2 it's advertising entry 2, and for R6 it advertising the entry 6 into the segment routing domain. And if you check this show ISIS database in the LDP domain, you will find that same information there, because database is same all across the IGP domain, right? But these routers are not running the segment routing, so it can't do anything with these prefix-sid values. So now if we check the trace route from the R1 towards R6, now here is the proper label for us. R1 has pushes the 24005, the label which he has received from R2. R2 swap it with the 24010 label which he received from R3. R3 swap it with the segment routing label, that is 16006. R4 swap with the same label value 16006, and R5 is the last hop to the R6, hence it is penultimate hop popping. Let's check the entry on the R5. So earlier we check it for the R1 and R2. So you can see that entry has been populated with the segment routing label. So if we go back to the earlier output where it was marked as unlabeled, and this is SAP entry where it is saying that label imposed is segment routing label, and this is labeled SR. This is labeled SR and label imposed is 16002. So if you try to trace route from R6, so 24009, it has pushed the label which he received from R5. R5 swap it with the segment routing label, that is 16001. R4 swap it with the same label, that is 16001. R3 swap it 16001 with the 24002, the LDP label which he received from the R2, and R2 is directly connected to R1, hence it is penultimate hop popping. So let's try to run the SR-MPLS here. So it's no label because on the R1, R2 and R6 we are not running the SR-MPLS, so hence you will not get any output for that one. But if we trace route the MPLS, so we should get same entry whatever we got for the normal trace route. So you can see here last it's saying that implicit null value with exp0. So this is how we need to configure the mapping server. Whenever we need the prefix-sid entry for the non-segment routing prefixes into the segment routing. Thank you for watching. And